Hey, hello guys, welcome, vanakkam, vandanam, namaskaram. Today we are going to see part 1, in that part 2. Okay, like last part I've taken only till around 14 minutes. Okay, actually it was supposed to be 1.5 hour session, but I got confused in the middle of the session, so here I am again with the beginning of preparation of alcohols. Okay, so first we are going to see how to prepare alcohol. That means எப்படி கள்ளசாராயம் காசுவது. Okay, how to prepare alcohol in our home. Actually it's very simple. All you want is you want a hydrocarbon, then you want a halogen like a chlorine. Like chlorine is available, I think. Then you want a base like NaOH or KOH. That's it, you'll be getting your alcohol. Okay, but make sure you are having ethane, don't have methane, because ethane is what used to do this. Ethane will take you top. Okay, so yeah, I'm just kidding. Okay, see, here you are having your hydrocarbon, then here you are having your halogen, here you are having your sunlight. Okay, so we all know how to do this halogenation. Halogenation is where you are going to provide halogen, then you are going to provide H nu, then you will be having your hydrocarbon, that will become as your haloalkane. Okay, so to this haloalkane you have to use any base. That base should have a highly reactive metal. Okay, so that means here it is going to be like NaOH or KOH, but it should be aqueous. Do not take alcoholic, take always aqueous. Okay, so then after that you are going to have here your alcohol. And I know that I'm saying lots of okay. Like in the previous video when I was listening to it, generally don't listen to my previous videos, but when I was listening to it, I was able to find that there are lots of okays. Okay, not okay. Now we are going to see how to prepare alcohol from alkene. See, first step is what your catalytic hydrolysis is. What is your catalytic hydrolysis? Hydrolysis means addition of H2O. Catalytic hydrolysis means you are adding H2O in presence of a catalyst. Okay, in presence of a catalyst like an acid. Okay, so the acid can be anything, H2SO4, or it can be HCl, or it can be H2SO4 or HCl. And also we are going to see the mechanism difference. We are going to see it, but just we will listen to it first. Then one liner. You are having here H plus. Here you are having here H2O. Okay, not okay. Now this will be making a compound that is called as H3O plus. That H3O plus is actually unstable and it is having a plus. Here you are having electrons. Okay, not okay. Here you are having here totally 4 electrons, which means here it is negative. So one electron from here will go to that H3O plus compound, which is positive in nature. Okay, not okay. So that electron will go and react with the hydrogen. That hydrogen will actually it will go. Then I will explain it very clearly itself. Then that you will be having there H2O that will be actually combined with your alkane. Then that alkane will be like in cationic form. Then that will become as your alcohol by removal. Again one H. Even it's confusing. Okay, we will see here even. So how will you prepare alcohol from an alkene? First you will have to form H3O plus. This is what your H3O plus is. You are having here H2O. This H2O will react with this H plus. Okay, here you are having your H3O plus. And make sure that you remember this, that this plus charge is with this oxygen, not with this hydrogen. It is with this oxygen, because oxygen is the atom which gives its own electron, to this hydrogen, and then it makes this complex, this compound which is your H3O plus. That's it, very easy. Now hereby you are having your alkene. This alkene will be reacting with H3O plus. This alkene will be reacting with H3O plus, and always note this. See, not only here, in most of the cases, everywhere negative charge will be attracted by positive charge will be attracted by the negative charge, isn't it? Here you are having a positive charge, here you are having negative charge. Okay, so this electron will go and then it will be reacting. One thing you have to note, that is this electron will not go and it will not attack oxygen. Instead of that, it will go and it will attack hydrogen. Why? Because hydrogen is what actually being obstacle. Like you can see that the only place where this electron can go is and attack is this hydrogen, because that is what over there, that is what over here. Or also you can remember it like this. That means if you are beating this hydrogen, automatically this oxygen will be in pain. That's what this is. So here you are having one electron. This one electron will go and it will attack this hydrogen. So automatically this bond, okay, this bond, see it will go and attack this hydrogen. So because of that, this bond will actually go here. How is it going? See, when this electron goes and then it attacks here, then you will be having here this negative charge will be gone. How is it going? See, our prime motive is to take this negative charge. So the only way to take that negative charge is like this cannot directly go and it cannot attack this oxygen, because these three hydrogens are actually safeguards, okay, safeguard for this oxygen. So what this electron will do is it will go and it will be attacking this hydrogen. So automatically, since it has attacked this hydrogen, this bond will break. Okay, this bond will break. So now you will have your H in a different place, and this, okay, here this will be going, this will be gone. Then this will go. Okay, one electron from here. This electron will be here only. It's not going anywhere. See, this electron is this oxygen. This electron belongs to this oxygen. This electron will go to this oxygen. Because of that, this positive charge will be gone. Okay, it will just go. The positive charge will go. So then you'll be having your H2O molecule. So your H2O molecule is there. Now you can see that since this carbon has lost one electron, so this carbon will be gaining its positive charge. So you will be having this one, and this hydrogen will go and it will react here. Okay, this hydrogen will go and then it will react to a carbon which has less number of hydrogen. So which means you will be having it like this. So here you are having here carbocation, and in this water is there, right? This water which has gone as a byproduct, that will be here only. So this water, what it will do is it actually tries to make a bond with this carbocation. How and why? See, here this will be having here. Okay, totally there are 4 different electrons with this oxygen. Okay, so this one is going, okay, this electron is going over here. Then they will be making a compound like this. Now you can see that this positive charges with this oxygen, because here oxygen is the atom that gives positive, it gives its electrons to this carbon, and then it makes a compound like this. Then you will be having this compound. This compound again it will be reacting with H2O itself. So from this itself, you can say that there are totally 2 H2Os that are required. One H2O is this H2O. Okay, that one lasts till over here. Then from here you want another H2O to react. But we will not mention it over here. You will not mention it over here. I don't get it. Why am I repeating some sentences and why am I saying always okay even though I don't get any reply? See, here you are having your, this compound is there, right? Again the same process happens. Again the same, okay, electron goes and it reacts with this hydrogen. So because of that, this hydrogen will go. Then this electron will come here, so that this will become stable. Then you'll be getting here H3O plus as your byproduct. So as I said, as I've already told to you that only one thing you have to remember, not only here, in most of the cases, to nullify this positive charge, what you have to do is you have to give one electron to here. But unfortunately, this electron cannot go directly to this oxygen because there are these 3 hydrogens which are protecting it. Okay, so for that, this electron will go and it will attack this hydrogen. Because of that, hydrogen which has 2, now there are only 2 different electrons. Okay, this electron and then this electron which is over here. This is the electron that has come to attack it. So this hydrogen will grab one electron and it will just like it will just run. Then this electron will go and it will be nullifying this positive charge. Or till now, even though I have explained all these and you cannot understand, then we will just give another explanation which is very good. Here this is positive charge, okay, here you are having a negative charge. So this, here is one electron, here is one electron. So automatically one electron will be attracted by that positive charge and then it will go. So that will be going and then it will be attacking over. It will try to attack here, but unfortunately it cannot. So it will go and then it will attack this electron, okay, this electron. Even though it is being attracted by this, but it will go and then it will be attacking this hydrogen, sorry, not electron, this hydrogen, it will go and it will attack. So because of that, this hydrogen will just break its bond with this oxygen atom. Then here you can see that here is one electron, here is one electron. So this electron already belongs to this oxygen, so you will not count that electron. This electron only it was with this hydrogen, so you will just take this electron into the account. So this will go and then this will react with this oxygen. So because of that, this oxygen will become just H2O. So yes, this will become, this positive charge will be nullified and then you will be getting H2O. So this H2O will be having here one electron, here one electron, here one electron, and then here one electron is there. So since this carbon has lost one electron of it, this will be becoming as a carbocation. So this electron, now what will happen is this electron will come and then it will be attacking this this time this will directly attack this carbon itself. Like, because here you are having no obstacles, like there is no bodyguards for this carbon, there is no hydrogen. So because of that reason, this oxygen will directly go and it will attack on this carbocation. Then you will be getting a complex, not a complex, a compound like this. Okay, this time one thing you have to notice that since this oxygen is the thing that is giving its electron and then it is making a bond with this carbon. This time this oxygen is the thing that is going to have positive charge. Now what will happen is again another H2O will be combining, okay, will be reacting with this particular compound. So this is having this is having electron, so that electron will go and then it will try to attack this positive charge, but you can see that there is an obstacle which is your hydrogen. So this will go and will attack this hydrogen. So since this hydrogen is being attacked by this electron, what will do, it will just run. It will just run. So now you are having here one electron and then here is one electron. So this one electron, it will go and it will combine with this oxygen. Now you can see that here you are having an alcohol, then here you are having your H2O plus. That's it. So from this we can say that this particular compound, to prepare this particular compound, you had the need of two different water molecules. Now I'm feeling kind of satisfied. Okay, so this thing, the preparation of your alcohol from your alkene is what known as catalytic hydrolysis, because in presence of a catalyst which is an acid, you are actually hydrolyzing it, which is addition of water to that particular compound which is your alkene. Now here you are having your hydroboration. What is your hydroboration? Actually you are adding a hydrogen and then boron compound to an alkene so that you can get an alcohol at last. So this is not your alcohol, this is your alcohol. At last you can get an alcohol. This process, okay, the process of addition of hydrogen and boron compound to an alkene so that at last you can get an alcohol. This is the process that we are going to check. Very simple, very easy peasy lemon squeezy thing. Like till now, just remember this, that is, you are having an alkene. So from this alkene, if you want to prepare an alcohol, there are totally two different methods. One is going to be catalytic, hydrolysis. Then second one is going to be your hydroboration. Like, see, in this entire organic chemistry kingdom itself, if you take, if we have to be very strong in it, only one thing we have to do. No, sorry, two things we have to do. First is we have to keep all the reactions into our brain, which is okay, which we can do. But second is we have to apply them with questions. If in case you are having very good applicable brain, that means just by looking at these theories, and if you can understand, and then if you are able to apply it into questions without doing any questions, then you are the king in organic chemistry. But lot of people, including me, we cannot just relate all these concepts directly to questions. For that we have to do at least 15 to 20 questions in order to relate everything 100%, in order to resonate with each other. Okay, so next is we are having here hydroboration, and I'm using lots of, okay, even though I'm trying to chop them. See here you are having your propene. Example I'm taking. This is your alkene. So to this alkene you are going to add your hydrogen and boron compound. That is going to be your HBr3. Sorry, BH3. BH3 twice. Which is going to be this. Which is going to be this. This compound I'm going to add. Actually here it is in molecular form, that is in direct formula form. Here this, what will happen is this compound, okay, so this compound is there, right? It will amongst this H, this will break its bond, and then it will go and then it will add over here. Then this hydrogen will go and then it will add over here. Because this will become like H plus BH2 minus. Like this it will become. Like this it will become. So now this is the negative part, this is the positive part. Now you can actually remember like this. This is actually opposite to Markovnikov's rule. Hydrogen will go to the highest. Okay, hydrogen will go where? Hydrogen will be going to high number of hydrogen only, right? So that means actually hydrogen should go here. But you can see that hydrogen is not going here. Instead of that your negative addendum only is going and it is going to react over. It is actually going and it is reacting over here. Okay, and this hydrogen is going to the least hydrogen carbon. This is the thing. This is actually completely opposite to Markovnikov's rule. So here you can see that here you are having this compound. Now since this has gone here, now you will be getting this. Now again what you have to do is you have to add this compound itself again, the same compound which is propene. So this propene should be again added here. Now what will be happening is, now you will be getting this itself twice, like this itself twice, because this will go here, okay, and then it will be reacting over here by breaking this one bond. By breaking this one bond, it will go and then it will be reacting over here. Then you will be getting a compound like this. Then along with that, one hydrogen will escape. Okay, only one hydrogen from here will escape. Then you can see that you will be having a compound like this. Now it's very easy. Why are you actually adding this over here? So that you can actually corner it. You can alienate this particular molecule, which will be like this, okay, which will be like BH. Okay, again you are trying to alienate it. Like the main motive for us is to remove this hydrogen. Our main motive is to remove this hydrogen. So by removing this hydrogen, what we can do, we can very easily remove this boron. We can very easily remove this boron. How can we remove? Just now I said now you can add any compound like highly reactive. Wait a second. Correct only. Whatever I'm saying is correct. Actually, I thought suddenly whether boron symbol is Br or B. B only is the symbol. I don't know why did I get confused. Okay, so here you're having this. What did I come to say? I forgot. My brain is very weak. It's becoming very weak. So here you are again adding the same compound. So this time it will become as thrice, and here you will be having your boron. Now what you can do, you can add here, you can add your hydroxide, which is H2O2. Then you can also add your H2O. So by adding your H2O, you can very easily get your alcohol. How can you get your alcohol? You can get your alcohol by just OH will be added to here. OH will be added to here. Then from this again 3 OH will be there. Okay, see totally there are 4 OH. Means that 1 OH will go and will add to this alcoholic compound. Then remaining 3 OH will go and it will be added to here. Okay, so it will be added to this boron. So you will be getting here trioxide, boron trioxide, and you will be getting your propanol. So propanol. So this is also a method. So yeah, catalytic hydrolysis is also a method which is very easy. This is also a method which is hydroboration. And make sure that you just remember it. That is, it is opposite to Markovnikov's rule. Hydroboration is actually opposite to your Markovnikov's rule. Only 1 second. actually a negative addendum should go to least hydrogen, correct, and hydrogen should go to the max correct only. Okay, it is opposite. Next is the carbonyl compounds. What are carbonyl compounds? Like you can see that actually you are going to prepare alcohol from carbonyl compounds like aldehyde compounds, like ketonic compounds, like carboxylic compounds. By using all these, you are going to prepare alcohols. So till now we have seen preparation of alcohol from alkane. We have seen the first thing itself. I explained that mentally. So then from alkene also we have seen. Now we are going to see it from carbonyl compounds. Okay, so first is from aldehyde. So you are having here aldehyde. Only one thing you have to do, that is you have to hydrogenate it. And we all know that while hydrogenating you have to add catalysts like palladium, like platinum, like nickel. Then you'll be getting your particular alcohol. Okay, next is you have to do ketone. Here also same hydrogenated. But the thing is, when you are hydrogenating aldehyde only, you have to use these specific catalysts. But over here, when you are hydrogenating a ketone, you have to use either NaBH4 or LiBH4. Okay, and that's it. Yeah, nothing. Other than that, you don't have anything. But you have to note one thing, that is, you will be getting a secondary alcohol. Here you will be getting a primary alcohol from this. Okay, so from this you will be getting only secondary alcohol from ketone. From aldehyde only you will be getting primary. Next is from carboxylic group. By two different methods you can actually do. By using two different methods. First is by giving an alcohol itself, you can prepare alcohol, and the second method is by using LiAlH4. See, in ketones, what did we use? We used LiBH4 or NaBH4. Didn't we use this only? But coming to carboxylic group, you have to use either LiAlH4, or you have to use here LiAlH4. That's it. Okay, so that's it. And along with that, you have to also use H2O. Water along with LiAlH4 is actually must ensure. So from that you can get your primary alcohol. See, in this carbonyl compounds, you are having aldehyde, ketone, and then carboxylic. Only one compound, only one part, amongst this carbonyl compound can give you secondary alcohol, which is your ketone. Ketone is the one and only compound that can give you secondary alcohol. Here also you can do like some other things, but directly I am talking about. Next is, here you are having same. See, wait inside 1 second. Here you can use two different things, that is LiAlH4 then ROH. These two you can use to prepare alcohol. So here you can see that here I have used this, so it will go like as a byproduct, H2O will go. Then after that you will be getting a compound like this. This R dash will go and will be reacting with this. Okay, then you have to hydrogenate it. Then after hydrogenation you can get your particular compound, which is your alcohol. Okay, perfect, amazing, good. So preparation of alcohol from carbonyl compounds. Once again, from carbonyl compounds. Actually, it is of three different types. First is your carboxylic group. Okay, next is your ketone. Then, great. Oh my goodness, how weak is my brain? Your aldehyde. Your aldehyde. So here you can actually use palladium or platinum or nickel. And as main product you have to hydrogenate it. Here you will have to hydrogenate it. This is what happening in aldehyde. Then over here you can actually use here either NaBH4 or LiBH4. And as a main product, sorry, as a reactant, you have to give here hydrogen. Here, what you can do is you can use here either LiAlH4 or you can use here ROH. And in the first time when you are using here LiAlH4, you have to give here water, and in the second time, like when you are using this one, you have to give here acid, respectively. So this is how you can do it. This is the case how you are going to do it. And also when you are using this one, you have to also use acid. Okay, when you are using alcohol, you have to also use acid. So this is your general preparation. Then after that, what do we have? One second, from carbonyl groups. Perfect. One thing. This process, okay, so that starts from here and it ends from here. It is what known as esterification. Alcohol, phenols and ether, in that you are having esters, okay. So this is what your ester. If in case you are having an exam, okay, a main exam, not a main exam, you are having an exam tomorrow and you have not yet even started to prepare, like you are watching this video and here is the place, and in that you are having a question that form ester from a carboxylic acid, then you can just answer this. Okay, this will also be lectured by me in esters also, but you can just remember that esterification is actually something that you do to carboxylic acid. Okay, this is actually esterification is where the process of creation of esters, not only from carboxylic acid, from others also, but this is how we will be doing esterification to carboxylic acid. Okay, perfect. Next is Grignard's reagent. By using Grignard's reagent, very important thing this is, by using Grignard's reagent also you can very easily form alcohol. From aldehyde only, like this is from carboxylic acid, so this is from ketone, this is from aldehyde. So from aldehyde itself there are totally two different types. First is, sorry, from formaldehyde you are actually forming, not from aldehyde, from formaldehyde you are forming, not from aldehyde, from formaldehyde. Okay, so from Grignard's reagent, in that by giving formaldehyde you are actually forming, by giving formaldehyde you can actually form alcohol. So first we will understand what is formaldehyde. Before coming to this topic, I did not know what is formaldehyde. If you know what is formaldehyde, very well and good. Okay, next is we will check what is Grignard's reagent. Already in haloalkanes and haloarenes, I said one time what is formaldehyde, but sorry, Grignard's reagent, we will just see it. Okay, again, not a problem. So Grignard's reagent is a compound that has been formed from a haloalkane. So its structure is very simple, RMgX. One speciality is that actually, see, Grignard is a person, and he was actually doing research, and he wanted a specific compound where this group, this R group also should be negative, and then this X group, that is your halide, also should be negative, and then your it should be negative, and then they should be having a bond with each other. That means this is a compound that should exist. He wanted to make a compound like this. Do you think is that possible, to make a compound like this and then to make a compound like this? No, it's not possible. It is not possible to make a compound like this, but he did it. He turned impossible into possible. That's what scientists do. Okay, now you might have a doubt, like how did he make that? Very simple. He just added here magnesium. By adding magnesium to it, he made a compound like that. He made a compound like this. So this compound, okay, this is what the general structure of the compound RMgX is what the general structure of your Grignard's reagent is. Then coming to your formaldehyde. What is a formaldehyde actually? Formaldehyde is actually another organic compound. So its structure is going to be HCH double bond O. Okay, so that's it. So by combining this and in this, you are going to have your alcohol at last as your byproduct. Now we are going to study that. Okay, so this, then this. And I'm using lots of okays, I don't know how to stop it. Now to this, I think I've said to you all this thing that is going to be, when you are having your Grignard's reagent, automatically your brain should go to ether. You have to add here ether. Then only the project that you are doing will be successful. Then after that, you have to also use here acid water. Not acid water. Yeah, okay, acid water is also okay. In Tamil, I'll be saying like, how I remember this is, like you can use lots of mnemonics to it. Not only here, you can use to entire organic chemistry, even though you can remember something, but for safety side you can create and keep mnemonics. Like how I remember is, like Grignard is a very ugly person that he has to take bath in acid water. That much he works in the laboratory, that much he works with grease, with all those substances. So because of that, he has to clean himself by using this acid water. That's how I remember. I know it's very not so good, but you can keep, because he is the fellow who gave us this headache now. So what? So we are just punishing him by our thoughts. Actually, it's up to us to think knowledge as headache or to just take it as granted. Actually, we should not take it as granted. We should take it with gratitude, and it's the hard part. Now, one thing we have to do, that is the mechanism. Which mechanism we are going to study. So, light color. This R is there, right? So this R, it will go and then it will be reacting with this C. Both are organic compounds only. This will go and then that will be reacting with that. 1 second. Correct. 1 second. Here you are having what? Here you are having double bond. You are having here. You are having oxygen, right? Okay. So this will go and then it will go and it will be hitting on this carbon. So now what will happen? So here it has gained a negative charge. Automatically here this will be having a repulsion and then this will be gone. Like this one will be gone. Like one bond will be gone. This R, okay, from this will go and then it will just attack this group. So from that you can, yes, correct. Okay, this will go and then it will go and it will attack this carbon. So from this bond will be broken. But the thing is, why R is going and attacking? Why R is going and attacking? Okay, see, this is what? This is negative, this is positive, then this is negative. Generally keep that this carbon is, this is negative, this is negative, inductive effect. You can just think like this. Whatever you want you can think, because there is no definition that they have given and they will not ask why R is going and will be and it is attacking here. So because of that, this will be gaining a small positive charge. Okay, so this will be going and then it is going and it is attacking over here. Now since it is going and then it is attacking over here, now here this positive charge will become as, this will be nullified. So because of that, one bond will go, so that this charge can also be nullified. then now you will be getting a compound like this. That is going to be CH then R, then O, then Mg, then X. Actually, as I said, this and this goes and it attacks over here, right? Okay, so this will go and then it will go and it will be attacking over here. This will go here, this will go here. Because, and you can see very clearly that this is actually, as I said, this is negative, this is positive. So this negative and this positive will be making a bond over here. This negative and in this positive, you can just keep it as, since inductive effect is there. Okay, so then it will be making a bond over here. Very simple, very easy, isn't it? Now you have got a compound like this. Okay, so then after that, what did I say? You have to use acid water. Here ether, I'll use this color, ether. Then over here you have to use acid water. Which color? Okay, so you all know that. Now only one thing we have to do, that is, if in case you are able to take this compound out and you are able to give hydrogen to this oxygen, and then it will become as your alcohol, right? So that is what we are going to do. From this, what will happen? Automatically from this you are having OH minus. See what will happen when you are having this H plus and H2O. It can become as into its constituent ions, that is H plus and then OH minus. So here this bond will be broken by hydrogen will be acting over here and then OH minus will be acting over here. OH minus will be acting over there and then hydrogen will be acting over there. Very simple. This is negative charge, this is positive charge. So that is why hydrogen is acting over here and then OH. See, this is a positive charge, then this is a negative charge. So this is going to act over here. Yeah, everything is just based on charge. Positive, negative, positive, negative, positive, negative. That's it. Only this thing you have to remember. So CH, RCH2OH, you will be getting a compound like this. Then plus as byproduct, you will be getting a compound like this. MgOH. Okay, XMgOH. Everything is stable, everything is correct, and you have got everything. One thing, okay, in MCQ, if you are having, like, they might ask you a question that you want methanol. Sorry, not methanol. You can, example, you want ethanol. Okay, you want ethanol. So at last you can, okay. So you want ethanol, and then they have given you options. Which of the following can be used as your Grignard's reagent? Your formula, that is N minus 1. N minus 1. That is your desired product. Here, this is what your desired product is. What they have asked is that you want ethanol. Okay, so for an example, you just keep it as ethanol. That is CH3CH2OH. Okay, so this is having totally N number of carbons. So the Grignard reagent that we are going to use should be having N minus 1 number of carbons. This is something which you can use by using this. Just by calculating in your brain, you can very easily find which of the following can be used as your Grignard's reagent. Next is from alkyl halides. Okay, from alkyl halides. I know I'm being a Kanjapasnari, but the thing is, I don't have space in my smart board. Sorry. Cheers are too loud. Okay, so from alkyl halides. See, This is also an alkyl halide 20. What did we do over there? We just added a hydroxide which has highly reactive metal, didn't we? That same thing only we are going to do here also. So, okay, here you are having. Yeah, I already explained this now. So then what? But one thing. Okay, KOH is also okay, but also you can use here aqueous AgOH. Okay, aqueous AgOH. Even though Ag is not highly reactive, this is an exception, so that is why I have written that over there. You can also use AgOH. Okay, so that means this is not recovered, so that means I don't have to take antidepressant. Okay, so this is how you are going to do from an alkyl halide. Okay, so this entire thing, like from this to this now, then you are preparing alcohol from a hydrocarbon. From this to this now, then you are preparing it from an alkyl halide. That's it. Okay, so then after this, oxymercuration. Mercuration and demercuration. This is actually none other than your Markovnikov's addition. Okay, so what is actually what is this oxymercuration and demercuration? It is where, wait, I will just say first of all, this is also from alkene. You are not trying to form, you are actually forming alcohol. Like till now, I think, except here, okay, from Grignard's reagent you did, but here from different compounds you did. Here from alkene only you did. Okay, yes, alkene. This is also from alkene only. In that one subdivision is oxymercuration and then demercuration. Okay, so first of all you are having your compound that is going to be CH3, CH double bond CH2, CH3, then your CH3. Okay, so this is your alkene that you have over here. I'm going to also say this with an example like I did over there. Okay, like with this compound. Now for hydroboration we talked with N-propene, right? The same thing. By the way, that is N-propene. Okay, so what about its name? This is going to be 1, 2, 3, 3, dimethyl 1, 2, but-1-ene. So this is what its name is. Okay, so not okay. 3,3 dimethyl but-1-ene. Today we are going to see only preparation of alcohols. Like with that, even my leg has gone tired and sore. So now here you are having CH3, COO twice of Hg. So CH3COO twice of H3. This is what your mercuration is. Where you are actually here you can see that here you can see that there is a halogen. Sorry, mercury. So that is what you are actually mercurating it. You are mercurationing it, oxymercurating it. Okay. So how will you actually oxymercurate? And also you have to use here THF. What is your THF? It is your tetrahydrofuran. Tetrahydrofuran you are adding to it. So from that you can actually get it like this. One thing that I have to say is, see here you can see that there is double bond. Always double bond is a thing that is going to be broken. One CH3CO from this one bond is being broken up. So that means what, one hydrogen also should be gone. So one hydrogen will be gone. First one you will actually get a product like this. CH3, CH3, then again CH3, then here you can see there is CH plus, then one CH2, Hg, CH3COO twice. From here there are totally two CH3COO. So CH3COO, among that only one CH3COO, then one hydrogen. Okay, so one hydrogen they will become, and then they will be going out as your carboxylic acid. Okay, then you will be getting a compound like this. One second, here 2 will not come now. Okay, so this is what you will be getting. Then after this you have to give water to it. Why are you giving water to it? Now you are actually demercurating it. So you can demercurate it by adding water. Okay, so that means what? This means now we are going to have a compound like this. So actually now you are not demercurating it. Later on only we are going to demercurate it. Sorry. But here you are mercurating it, but then you are going to do demercuration after this. Okay, so now only you are demercurating it by adding like NaBH4. Okay, then by adding NaBH4, then also by adding OH minus. So by adding this you can actually form CH3, 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 then CH3OH. Okay, so because of that this will just go. Okay, this compound will just go. That means you are just cutting this compound, then you will be having this compound. Actually, see here what is happening here. One CH3 from here one hydrogen has been removed. Where is that? From here one hydrogen has been removed, and then from here one CH3COO is being taken. Then they both will combine, and then you will be getting CH3COOH. Okay. Then after that After that, you'll be getting a compound like this. Now what you're going to do, you can add H2O. Okay, by adding H2O to this, I mean from this H2O, OH will be taken out, that OH will be added to the specific spot. So that is what's happening over here. Okay, then after this, again you are going to add OH minus. This time you are actually having only OH minus, then you are adding NaBH4. So when you are adding this, automatically this bond breaks, then you will be having your alcohol only. That is this alcohol, and here this is a secondary alcohol. Okay, so this is what oxymercuration and then demercuration is. Next is MPV reduction. What is your MPV reduction? Actually, here we are having alkyl exchange and then we are having oxidation. Wait a second. MPV reduction. This is alkyl exchange reaction. Okay. See, now we are having R, C, R, double bond O. Okay, so to this we are adding, you can add any secondary alcohol. So I'm having here CH3, CH, 3, OH. Okay, so this is what your MPV. See, actually MPV reduction, or we can also say this has exchange. Okay, exchange, you're just exchanging. Exchange will be written now, then what? Okay, alkyl exchange reaction. That means what? Alkyne is being exchanged. That's it. Okay, so in presence of propoxide and then heat. Okay, sorry, aluminum, no need of heat. Okay, you want only aluminium isopropoxide, that one. Then you will be having just this part will be exchanged by this part, like there is just exchange. Specifically this part, then this part is being exchanged by this part. Okay, so that means what? Now you are going to have R, CH, OH, R, CH3, C, double bond O, CH3. Now we are going to have the plus CH3, C, double bond O, CH3. That's it. Okay, so this is what we are going to have. Okay, so we are going to have this, which is a secondary alcohol, and then this is actually another product. Okay, now if you want to reverse it, like from this, if you want to get it again this, okay, from this if you want to get back now, then what you have to do is then you will have to add aluminium, this time tetra butoxide. Then from this again this will be coming. Okay, so this reaction is known as MPB reduction. So this one is actually known as Oppenheimer's oxidation. Actually, one thing, if this is reduction, then this is going to be oxidation only. Here you are reducing and here you are oxidizing, that's it. Okay, so then now we have physical properties. Like based on physical properties and then some chemical properties, we will be getting questions. But mostly we will be asked questions from chemical reactions and then preparations only. Okay, so we will end this video here even. We will be meeting in another amazing video. Till then, bye bye.